This is the scariest planet in the solar system, a frozen planet drifting nearly 5 billion kilometers away, so distant that sunlight takes 5 long hours to reach it. Yet even after that endless journey, it brings no warmth at all. This is a prison of death, where temperatures drop to 230 degrees below zero. Any life form exposed to its surface would freeze solid in just 0.1 seconds, its body shattering like glass. Even blood would instantly harden into dark purple-black crystals. There is no air to breathe here, only deadly particles that could slice through human flesh. A single breath would turn your lungs into ice, riddled like a honeycomb. Today, we'll follow the lens of NASA's New Horizons spacecraft to unveil the haunting face of this planet of death, Pluto. New Horizons launched from Cape Canaveral Air Force Station in January 2006. Its mission was to photograph and collect data on Pluto and its moons. On July 14, 2015, 9 years after its launch, the spacecraft made its closest flyby of Pluto, capturing stunning images of its icy mountains, glaciers, frozen plains, and vast canyons. Scenes far beyond anything we had ever imagined. But because Pluto lies at the edge of the solar system, the probe's data transmission speed was only 1 to 2,000 bytes per second. It took 15 months to send all of the collected data back to Earth. Each time NASA released a new image, it caused a wave of global fascination and awe. Even now, when I look at those images, my admiration remains undiminished. Each frame holds layers of hidden information, and deciphering them feels like assembling a vast cosmic puzzle. As with all great puzzles, only patience and precision can reveal the full picture. Piece by piece, the face of Pluto slowly emerges. Let's begin with one of its most mysterious regions, the yellow-bronze claw near Pluto's equatorial belt. It is made up of 6 broad lowland areas, known as dark spots. Each dark spot spans roughly 480 kilometers across, about the size of Iceland. Close-up images reveal that these dark plains are interconnected by canyon-like networks. From west to east, they are named Kroon, Ala, Balrog, Vukubkam, Hunkam, and Mengpo, each drawn from ancient myths of underworld deities. Scientists believe that the deep, dark color of the yellow-bronze claw comes from a tar-like substance known as tholins. Tholins are carbon-based compounds formed when methane and nitrogen gases react under the influence of cosmic radiation. They are widespread across Pluto's surface, particularly concentrated in the nearby Thulu region. The 6 dark areas of the yellow-bronze claw appear separated because each is divided by high-altitude ice ridges, towering several kilometers above the surface. These icy highlands are thought to be composed mainly of frozen nitrogen and carbon dioxide, with layers of water ice forming the solid foundation beneath. In Pluto's low-gravity environment, water ice is as hard as rock, strong enough to build towering mountain ranges. At the same time, softer ices, like frozen nitrogen and methane, flow more easily, slowly filling the planet's lowlands and craters. It's not hard to imagine how breathtaking it would be to stand in one of Pluto's vast canyons, looking up at immense glaciers rising on every side. After all, ice is the most abundant material on Pluto's surface, making up nearly 98% of what we see. The most recognizable feature of Pluto is its heart-shaped region, officially called the Tombaugh Regio, named after its discoverer, Clyde Tombaugh. This massive star-like shape is made almost entirely of ice. Its western half is a smooth, flat basin known as the Sputnik Planitia, an enormous frozen plain of nitrogen ice. The eastern half, by contrast, is rougher and more mountainous. In high-resolution images, we can clearly see the difference, as if Pluto's heart were divided between smooth and rugged textures. It's said that if you could trace it with your fingertip, the eastern half would feel thin and uneven, like the surface of an orange peel. Scientists believe that winds on Pluto lift tiny particles of nitrogen ice from Sputnik Planitia, carrying them into the thin atmosphere before they settle on the highlands to the east. This process explains why those highlands shine so brightly. The light reflects off fresh layers of frozen ice that have accumulated over time. Some of this material likely drifts back down again through slow, creeping ice flows, creating a natural exchange between the eastern and western halves of Pluto's heart. Although this kind of process is rare and difficult to observe, it reminds us that even this frozen world hides subtle geological movement. After all, every planet keeps its secrets. To the west of Sputnik Planitia lies a range of icy mountains known as the Tartarus Dorsa, sometimes referred to here as the Idris Mountains. Here, Pluto's faint but surprisingly powerful winds push grains of frozen methane and nitrogen ice across the landscape, depositing them like drifting sand. It's an astonishing sight, considering how thin Pluto's atmosphere is, only about 100,000th as dense as Earth's. These icy grains are lifted into the air through sublimation, a process in which solid ice turns directly into gas under sunlight. Once airborne, they cool and refreeze, falling back as tiny ice sand, which gathers near the mountains into a vast dune field stretching over 2,000 square kilometers. These dunes resemble those of Death Valley in California or the Taklamakan Desert in China. But unlike Earth's deserts, Pluto's dunes form in an environment colder than -230 degrees Celsius, and the grains themselves are much lighter than sand, almost like powdered frost. Under Pluto's low gravity, they would drift softly, feeling more like dust slipping through your fingers than grains of sand. But with temperatures plunging far below freezing, I wouldn't recommend trying to touch them. The Sputnik Planitia region holds more than just dunes. Near its western mountains lies a deep canyon, seen in images as a vivid blue streak. Measurements show that peaks close to the canyon rise between 200 meters and 1 kilometer, while those farther away soar as high as 3 kilometers, comparable to mountain ranges on Earth. This pattern, higher peaks farther from the canyon, may be a clue to activity beneath Pluto's icy crust. Recent studies suggest that Pluto might once have contained, and perhaps still hides, a vast underground ocean beneath its frozen shell. For a world so far from the sun, the possibility of liquid water is extraordinary. To sustain it, Pluto's core must still generate enough internal heat, perhaps through radioactive decay or slow chemical reactions within its rocky interior. Yet Pluto is smaller than Earth's moon. Its tiny size should make it difficult to produce such warmth. The evidence of an underground ocean on Pluto astonished scientists around the world. It's a fascinating discovery, but you might be wondering, what does this have to do with the mountains we just mentioned? In 2019, a study presented at the Lunar and Planetary Science Conference suggested something extraordinary. The Idris Mountains may have slowly drifted eastward through a process known as solid ice flow. This gradual movement could have carved the deep trenches seen on the eastern side of the range, and may also explain why the mountain peaks rise progressively higher from west to east. If this theory proves correct, it would mean that Pluto's surface is still active, and that these movements are being driven by the presence of liquid water beneath its icy crust. Beyond the mountains and their valleys, the Idris Range itself offers more clues supporting the underground ocean theory. Using the highest resolution color images ever captured, the New Horizons team combined data from the Long-Range Reconnaissance Imager and the Ralph optical camera to reveal the Idris Mountains as an enormous structure composed mainly of water ice, rising nearly 4 kilometers high, with a massive trench running through its center. The lack of similar trenches nearby suggests that the Idris Mountains may still be geologically active, perhaps even shifting or deforming in the recent past. Scientists have also identified another hidden formation, Picard Mountain, which is even larger, reaching up to 7 kilometers in height. Unfortunately, when the New Horizons probe captured its data, Picard Mountain was shrouded in shadow, so its images are not as sharp as those of Mount Leith. Still, in the color-enhanced terrain maps, you can clearly see its silhouette, and at its summit, another large crater-like depression. These depressions resemble volcanic calderas on Earth, but the proportion of their size compared to the overall mountain is much greater. Close-up analysis shows that the trenches are surrounded by concentric rings, hinting that these features may have experienced multiple eruptions. After each event, material would have retreated inward, causing the mountain to collapse and reshape itself. Just like an ice volcano or cryovolcano, erupting frozen materials instead of molten rock. To be clear, scientists have not yet confirmed that these are true volcanoes, But the growing body of evidence makes the idea increasingly difficult to dismiss. This is yet another remarkable feature of the Idris Mountains, and possibly another sign of Pluto's hidden, living geology. If Pluto really does possess an underground ocean, future research could uncover even more extraordinary secrets. Who knows? Perhaps one day we might even find signs of life beneath the icy crust of the Idris Mountains. Will humanity ever send a probe back to the Kuiper Belt to explore it up close? There are already proposals for such missions. But even with today's technology, the journey would take over 20 years.